This is the last video that's designed to go with section 14.3 of the Mathematics for Elementary Teachers book by Musser. So in this last video, we're going to be constructing a line parallel to a given line through a point that's not on the line. And you can see the point and the line that I've already drawn. So we are going to, for reference, put in a point Q on the line and a point R on the line. And we're going to draw with a straight edge or a ruler the line going through PQ. The reason that we're doing this is because we're going to use the concept of alternate interior angles being congruent in order to verify that we are making a parallel line to the line L. So in order to do that, we need to create the same angle up here at angle P, because I want to be able to create a parallel line here, so the alternate interior angles must be congruent. So I need to just copy what we did in video 1 by copying the angle. I need to copy angle PQR up here so that the vertex is at P. So we just have to repeat the process from the first video. So what we're going to do is we're going to measure the length of QR with our compass. So put the point of your compass at Q, get the pencil onto R, measure that distance, pick it directly up, rotate it so that the point is now on P, and make an arc to represent that length. Okay, now we're going to measure the distance between P and R. So we're going to make sure that we have this directly on points P and R. Because remember, the idea behind this concept is that we're making a side-side-side congruency, because we're going to have this side because of reflexive. We're going to know this side because we just did that with the arc. And now we're going to know the third side when we use point Q. So this is the length that I want. I'm going to move over here to point Q. And I'm going to make that arc. Where the two arcs intersect is a point. So I'm going to put that point in. And now if I connect those dots and draw in the line from P to the point that we just created, we should have a line parallel to line L. And you can verify being parallel because they should be equidistant apart the whole time. Now, you will have a little bit of human error just because of the width of the pen or the pencil and where you put the dot, okay? So it is going to be reasonable that you might have it off by a millimeter, but the idea behind it is still solid. So what have we effectively done? Because we wanted these two angles to be the same, all right, because alternate interior angles will mean parallel lines. What we did was we took the reflexive property and we said PQ is going to be congruent to itself. All right. We plotted this point with the length of QR, so we know that QR is going to be the same as that point, or as that length. And then we took the length from P to R. I'll just put it in dotted here. And that's how we came up with this arc. And so we made this dotted line over here. And we basically said, okay, well, we have those two triangles with side, 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 And so those two corresponding angles must be the same. And there's our alternate interior angles cut by the transversal. So we're using that property here to create the parallel line.